Hello, dears. Good morning, and welcome to a new session. And in this session, we will be exploring the network architectural model, TCP bar IP reference model, which is a foundation concept in computer networking. And in this session, we will be covering its origin, layered architecture, key principles, and the function of each layer, and concluding with merits and its demerits. And coming to the origin and evolution of TCP bar IP, as you know, TCP bar IP is the backbone of any internet. So its expansion is Transmission Control Protocol bar Internet Protocol, and it was developed by the Department of Defense Project Research Agency, ARPA, and later it was renamed as DARPA. And it was a research project for network interconnection, and its goal was to connect remote machines and ensure a robust network connection. And before that, there was another previous model known as OSI reference model, which was actually included 7 layers and which significantly influenced TCP bar IP's development, leading to shared terminologies. So actually TCP bar IP is quite simplified, and it has 4 layers, with the updated version commonly used today has 5, and it's reflecting its revolution. Then coming to the key design principle. When we are thinking about the design principles or design aspects, it has, first and foremost, it has a flexible architecture. This network model has a flexible architecture, and it is designed to support a flexible architecture, making it easy to add more and more machines or nodes to a network. And second one is it has a robust network. It is providing a robust network, ensuring network robustness with connections remaining intact as long as source and destinations machines were functioning. And the third one is it allows application communication, allowed applications on different computers to communicate by sending data packets to each other. And coming to the layers, the 4 layers of the original TCP bar IP model consists of distinct layers with specific responsibilities and functionalities in facilitating the network communications. Okay, so when compared to OSI reference model, which has 11 layers, it is only having 4 layers. And the first and the topmost layer is known as application layer. And below that, beneath that comes the transport layer. And beneath that comes the internet layer. And the bottom layer known as network access layer. So first we are discussing about the topmost layer, which is the 4th layer known as application layer. And it defines TCP bar IP application protocols. And its key responsibility is how host programs interface with the transport layer services to use the network. This layer is where user applications interact with the network. And the very next layer is known as transport layer. And the transport layer is positioned actually in between the application layer and the internet layer. Its primary purpose is to enable devices on source and destination hosts to carry on a conversation. It defines the levels of services and connection status used when transporting data and ensuring reliable data delivery at the destination point. Then coming to the internet layer, the internet layer is actually situated in between the network access layer and transport layer, and its primary key functionalities, prime responsibilities for packaging data into IP datagrams. Then what are datagrams? Datagrams are the basic unit of transportation in the network. Actually, this datagram has a header portion and a payoff portion, that is header consisting of address and the data bits. These datagrams contain source and destination IP addresses, which are crucial for forwarding them between the host and across the networks. This layer also handles the routing of IP datagrams. Okay, then it operates as a connectionless network layer. It operates as a connectionless network layer, and The higher layers are responsible for reordering packets that may arrive in sequence. Then coming to the lowest layer, that is the layer 1, known as network access layer. And the network access layer is the foundation layer of the TCP/IP model, and it defines the transmission, physical transmission of data, including how bits are electrically or optically signaled across the hardware devices that directly interface with the network media, like coaxial cables, optical fiber, twisted pair cables, etc. Common protocols and standards at this layer include, you may be heard of that, popular Ethernet protocol, token ring, FDDI, X.25, etc. And Ethernet is the most popular LAN architecture, and it uses the technology known as CSMA/CD, carrier sense multiple access, bar collision detection, to manage media access and ensuring the data handling and data collisions, etc. Okay, then as a conclusion of our session, we can discuss about the merits and demerits of TCP/IP network model. When coming to the merits, the first and foremost is it operates completely independently. And the second one is it is highly scalable. That means we can add as many nodes to the network. Then third one is it supports client-server architecture, definitely this famous two-tier architecture. And the next merit is it accommodates various routing protocols, numerous routing protocols for each services. And it facilitates connections between two computers. And when we are thinking about the drawbacks, we can list out. First one is transport layer does not guarantee about packet delivery. And it has limited to specific applications only. And the protocol replacement is quite challenging in this case. Then it lacks clear separation between services, interfaces, and protocols. So I hope you understood the topic that we have discussed now, the network model and the famous TCP/IP reference model, which has 4-layered architecture when compared to OSI model. And we also discussed each and every layer with its functionalities and responsibilities. And finally, we concluded the session with its merits and drawbacks, demerits of TCP/IP. I hope you understood the topic very well. Thank you.